Section 3.4 is how we are going to be solving quadratic equations by factoring. Remember when we had our graph and we were asked to solve by graphing, your answers were your x-intercepts, your zeros or your roots. What we're going to do is we're going to algebraically factor this, which will look like this guy where you have two sets of parentheses. We're going to set those equal to 0, which is where the name zeros come from, because you're going to set those equal to 0 and then solve and find your x-intercepts. So some of these problems that we do, you'll be wanting to find the greatest common factor. So remember, the greatest common factor is the biggest thing that they have in common. So both of these have one x in common, so I can factor out one x. So if I divide by one x, I'm left with a. Divide by one x, I'm left with b. Same thing can happen with your numbers. Find your greatest number that you can divide both of these terms by. I can divide them both by 5. So 20 divided by 4, or 20 divided by 5 leaves me 4. 20 divided by 5 gives me 3. We are going to factor these trinomials so that our answers will look like this. So let's take a look here so you can see what this process looks like. So in this first one, it gives us 12x squared minus 2x equals x. Just like before, you want to get everything on one side so it's always equal to 0. So I'm going to minus my x from both sides. When I do that, I would get 12x squared minus 3x equals 0. First thing I want to do is find my greatest common factor. So step 1 always with factoring is doing that, greatest common factor. So the biggest number I can divide 12 and 3 by is 3. Then I'm going to see how many x's do they have in common. So what's the biggest amount that I could take out? So this x squared means I have 2 x's. This x means I have 1 x. So how many x's do they have in common? They only have 1 in common. So I can take out a 3 and 1 x. So I'm going to put that greatest common factor outside, and I'm going to divide, just like we did before, by our greatest common factor and write my terms left over. So 12 divided by 3 is 4. I'm taking out 1x from 2 x's, so I'm left with 1x. Then I'm going to divide 3 by 3, which is 1. I take out 1x from 1x, so I'm left with no x's. Once you've done this, you're going to set each term equal to 0. So this, not term, each factor. So this guy is its own factor, so I'm going to set that equal to 0. And this guy is its own factor, so I'm going to set that guy equal to 0. So then I'm just going to solve. So 3x equals 0, I'm going to divide by 3, so I get x equals 0. Over here, I'm going to add 1, divide by 4, so I'm going to get x equals 1/4. I like to always put my answer together, so I would write x equals 0 and 1/4. So if I were to look at this as a graph, this would somehow be a U shape where it's crossing 0 and it's crossing at 1/4. So it might be something like that. Okay, pause the video and try the next question. So on the next question, you should be adding that 5x over to begin with. So I would get 5x squared plus 20x. Then I'm factoring out my greatest common factor to begin. So I can take out a 5 from both of those, and the greatest common, or the greatest amount that these x's have in common is just 1 again. So it'll always be your lowest amount. So I can divide by 5 and take off 1x. So I'm going to write that outside of my parentheses and divide and write the terms left over. So 5 divided by 5 is 1. Take off 1x, I'm left with 1x. 20 divided by 5 is 4. Take off 1x, I'm left with 0 x's. Now we actually solve it. So I set 5x equal to 0 and x plus 4 equal to 0, and I solve it. So I divide, I get x is 0. I subtract, I get negative 4. Again, as a graph, that would mean my graph would be crossing at 0 and crossing at negative 4. So potentially your graph might look like that. Okay, now then, what if I move over, so on example 2, what if I move over my 18 and I don't have a greatest common factor? And that's what we're going to look at next. So I minused my 18 over, I got this guy. Now my greatest common factor is just a 1, so I can't do that step. Now you're going to tap back into Algebra 1, where we did these x's. So you're going to make an x. A times c goes on top. So I'm doing 1 times negative 27, which is negative 27. And b goes on bottom, which is negative 6. So remember, in a quadratic, A, B, C. Now I'm looking for factors of 27, which would be 1 and 27, 3 and 9. That's it. I'm looking for which set of factors will give me 6 when I add or subtract. So the set that gives me 6 when I subtract would be 3 and 9. I need it to times to a negative, but add to a negative 6. So that means that one of these has to be negative. I would need the 9 to be negative. So they add to negative 6, but multiply to negative 27. Once you have that x, and notice that I just rewrote it in a different order on this one, you're ready to set up 2 sets of parentheses. So I do one set of parentheses, the other set of parentheses. I put x's on the both of the first terms. And then my 2 numbers that I just found, I'm going to slide right in there. So that's where I'm doing x minus 9 and x plus 3. This is considered factor. So this is your number, your GCF, if you will, times what was left over. So just like before, you got to set each factor equal to 0 once you factored it out. So I set them each equal to 0, and then I solve. So add 9, subtract 3, put your answers together, so I get 9 and negative 3. Okay? Pause the video and see if you can do the next one. So on the next one, you would subtract over that 101. So this should be your equation you're working with. There is not a greatest common factor, so you should have done your x. So A times C would be negative 96. B goes on the bottom. So factors of 96, 1 and 96, 2 and 48, 3 and 32. I'm not sure, does 4 go into it? It does, 4 and 24, 5 doesn't go into it, 6 and 16, 8 and 12. And then that would be as many as I can do. So then I would figure out which set adds or subtracts to 4. That's why I used 8 and 12. I need it to times to a negative 96, but add to a negative 4. So anytime this bottom one is negative, that means one of these has to be negative. So my bigger number would have to be negative so that it would add to negative 4. Okay, so then I'm ready to write my 2 factors. So x minus 12 and x plus 8. So remember, x and x, fill in those 2 factors. Then set each group equal to 0. So x minus 12 equals 0, x plus 8 equals 0, and solve it. So add your 12, subtract your 8. Those are your 2 answers. Okay, so that takes care of part 1 of solving by factoring. So just a greatest common factor and then just kind of easing our way into this x so that we can do this piece of it. If you're needing day 2, so the second day that we were working on solving by factoring, this process is a little bit more in depth. So here is my equation. I'm already equal to 0, so I don't have to worry about moving anything over. Okay? First step I want to do is I want to check to see, do I have a greatest common factor? I don't, because all I can do is divide everybody by 1. So now we're still going to do our x. So step 2 is where you want to do that x shape. So I'm going to do A times C on top and B on the bottom. So now I have to do 2 times negative 3 for that top part as opposed to what we were just doing. Factors of 6. Factors of 6 are tricky because both sets actually give you 5 when you add or subtract. So you really have to pay close attention to the negatives. So if I need this bottom one to be negative, one of these has to be negative. And if I did that on this set, that would give me 1 or negative 1. So that's why this doesn't work for this set. So I'm using 6 and 1, and my negative has to be on the bigger number. Okay, now I can't do that shortcut that you and I were just working on previously. So now I have to do this whole process where you're going to drop down that first term, rewrite this. So this negative 5x is getting split into these two guys that we just found here. So you're not going to write this guy, okay? So I'm writing negative 6x, positive 1x, and then I'm dropping down that negative 3. Once you are here, you're going to split it again. So it's called grouping. So I am going to regroup here, and I'm going to do a greatest common factor. So I'm splitting it from the first two and the last two. So I'm doing a greatest common factor of this set. So greatest common factor for the numbers would be 2. Greatest common factor for the variables would be 1x. So I would take out 2x, and I would be left with 1x minus 3. On the second group, my greatest common factor is a 1. I still have to have a GCF here, even though it doesn't change anything. So I have a 1, and then I still have x minus 3. To find those two sets of parentheses, you're going to take these two GCFs and put them together into one group. And then you're going to take this guy, which should be the exact same thing, and it's going to be its own group. Okay, so it's like taking out the x minus 3 and putting it here, and then you're left with these two guys to put together. So once you have it factored, like we do, we're going to set them equal to 0, just like we did before. Okay, but this is the process we got to reiterate that you practiced before in Algebra 1. So you set it equal to 0, set it equal to 0, and solve. So add 3, subtract 1, divide by 2. Okay? So let's have you try one of those and see how you do here. So you would minus your 17 over. You would get this guy. It happens to be the same set of numbers we were just working with. So A times C and B. Now this is a positive 5. So again, tricky because both sets still give you 5 for factors of 6. But in order for this to be positive 5, both of these could be positive, but then that would not make this negative 6. And for this one, if you do it, it does give you 5, but your negative has to be on that smaller number. So very tricky numbers they decided to use for that guy. So then what I'm writing is 3x squared. This 5x gets split into these two guys right here. So I'm not actually using this to write it out. Then I'm going to split it down the middle, and I'm going to do my greatest common factor. So I'm going to take out my 3 and my 1x, and I'm left with 1x and 2. This guy is still going to factor out a 1, but anytime this first term is negative, you're going to pull that negative with it. Okay, automatic. So I take out a negative 1 and x plus 2. If you don't do that, then these two won't match, and then you'll be in a problem. Okay, so one of your groups is x plus 2. The other group is going to be 3x minus 1. Set them both equal to 0 and solve. So you should be getting 1/3 and negative 2. If you're still not feeling confident, you could practice one more time with this guy that I have here before you move on. Okay, so minus your 9 over, and then see if you can take it from there. So for your x, you should have gotten negative 30 on top, negative 1, factors of 30 that give you 6 and 5. So, factors of 30 that give you 1. So these would be all of your factors of 30. And so the only set that gives you 1 is 5 and 6. And then you have to make sure you put your appropriate signs there. So you drop down the 2x squared. You drop down the negative 15. We don't use the middle term. We use these two guys that we came up with. So then I split it, and I do a greatest common factor. So 2x goes here, x minus 3. 5 goes here, x minus 3. So my two groups are x minus 3 and then the 2x plus 5. Set them equal to 0, and then solve them. So I get negative 5 halves and positive 3. All right, so that concludes part 2. So if you are needing day 2 of section 3-4, that will conclude it. So just kind of showing you what that process looks like when you can't do the shortcut. Now we're ready for part 3. Okay, so on part 3, we're still going to be factoring, but there's some special cases that can happen. So if you end up getting x squared minus 4, this is a perfect square because it's a 1. 4 is a perfect square. So perfect squares mean that if you did the square root of them, it would give you a nice whole number. Okay? These are ones that you can try and memorize because it ends up having this same format every time. I'll show you what that looks like. Same thing down here. If you get perfect square, and then the sum is doubled between these two, or the product is doubled between those two, then that's also a special case. I typically don't have people memorize those. I just kind of show you what those look like. So here's some examples with those. So same process as before, we have to get everything on one side. So I would minus the 81 over because it's not nice to have this guy as a -1. Okay, I'm still going to do my x. So I'm going to put a times c on top. But think about what would be your b value. Because right now I have an a value and a c value, but I don't have a b value. So therefore your b value would be 0. And anytime that bottom number is a 0, these two things have to be the same. So it's always just doing the square root of this, and that would give you these two numbers. So I have to use 9 and 9, and in order for me to get 0, one of them has to be negative. So then, this is a nice little shortcut one because remember, if my leading coefficient is 1, I can do my shortcut where I just do x and x and I throw in these numbers. If my leading coefficient is something other than 1, then I have to do that full process. Okay, so try and remember that shortcut. Otherwise, you have to do the whole process that we just practiced. So you would do x squared plus 9x minus 9x minus 81 for that. And then you would split it and then take out your greatest common factor, take out your greatest common factor, and then you would still end up with the same thing that we got. So if you can't remember that shortcut, you can still do the whole process. Okay, but if you can remember it, it helps you with a little bit of shortening your time. And then you're going to set those equal to 0 and still solve them. So these would be my two answers that I would come up with. Okay, pause the video and try the second example. So hopefully you minused your 256 over this time because you want to keep that x squared positive. That b value is 0, so hopefully you did the square root of 256 and you got 16s, and one of them has to be negative. This is one I can use my shortcut on, so I would do x minus 16 and x plus 16. If you didn't do the shortcut, you still should have come up with the same thing. You would just write out that whole process, remember, and then still do our whole thing. So you would take out an x, take out negative 16, and still get x minus 16, x plus 16. All right, I got it factored into my two groups, so I can set them equal to 0, and then I can solve them. So you should be getting positive 16 and negative 16. Okay, continuing on, so you can see what these guys look like. So still the same before, move everything to one side. So I want to keep this x squared positive. So I'm going to minus my 26y and I'm going to add my 13 over to its like terms. So this is my equation that I have so far. Now remember, you always want to check for a greatest common factor. And so I've been skipping the step on that for the last couple of times because it hasn't occurred. But remember, if there's a leading coefficient out here other than 1, you want to go through and check, can I divide by anything? So I can take out a greatest common factor of a 4. And I'm going to do that because that's going to make my numbers smaller. So if you don't find it, that's okay. But if you do find it, it's helpful because then it makes your life a little easier in finding those numbers. So anytime that you have that greatest common factor out there, just throw that 4 down there as one of your factor groups that you're going to set equal to 0. Okay, so just throw it down there at the end, and then we'll come back and look at it. So I'm looking at this 4y squared minus 12y plus 9, and I'm going to go ahead and do my x. So a times c, my b. So this is another case where you have that perfect square. Okay, so I'm going to have to use 6 and 6 so that I can get that 12. That's where this comes into play. So I'm going to split it into my two pieces, and then I'm going to do my greatest common factor. The special case to this is that notice they end up being the same thing. That's why this is a special case. So if you can recognize, this one's harder to recognize versus the other one. This number has to be a perfect square. This number has to be a perfect square. And then when you multiply the square roots of them, so square root would be 2 and 3. 2 times 3 is 6, and then I double, it's 12. So there's a lot of math to figure to make sure that it fits this. So that's why I don't really press this one. But that other one with it's just an x squared minus a perfect square, that one's an easy one to remember that you need to recognize. And then once you have those solved, you can just set them equal to 0. So remember that greatest common factor that I had you throw down there? Is there a variable present in there? No. So this guy is not going to produce an answer. So you can just ignore this because there's no variable in there to produce an answer. But these two will produce an answer. And notice that you do end up getting the same answer because it's the same group, right? So I'm only going to get one answer. It's just that 3/2. Okay, pause the video and try that next question. So on the next one, hopefully you moved everything over correctly and you got 9x squared plus 54x plus 81. I can recognize those numbers are kind of big, so that automatically tells me look for a greatest common factor. So I took out a 9 and I threw that guy down there at the end. Okay, then I did my x and I found that 9 is a perfect square, so I did the square roots of them to get 3 and 3 to add to 6. This is one where I could use the shortcut on because my leading coefficient is now 1. So since I'm going to do that shortcut, I just have to do x and x, and then I throw in those numbers. Okay, so then I can set it equal to 0, and then I can solve it. Remember, this greatest common factor didn't produce an answer because there was no x to solve for. So this guy didn't produce anything. These two are the same thing, so that's why I just wrote it down one time. All right, folks, that concludes our practice with solving a quadratic equation by factoring.